Okay, so in this video we're going to be talking about how to work out volumes of 3D shapes. Now the reason why I've written easier shapes is because I have done another video about how to find volumes of shapes like pyramids, cones, cylinders, stuff like that. So that's in a separate video. This one we're just going to be focusing on cuboids, cubes, triangular prisms, and then a generic formula as well for ones that could be like compound shapes at the front and then made into a 3D shape. So we're going to start with the EG1. So this is a cuboid. You can tell because all the lengths are different. If they were all the same, then that would be a cube, and you would use the same formula as this. So the formula to find the volume of this shape is that you just time the length together. So we call this one length, depth and height. So all you do is multiply all those lengths together. Okay, some people do use different notation, so I call this depth, but I know some people call it width and stuff like that. But essentially you just times the size together. So we do 5 multiplied by 2 multiplied by 6, okay, which gives us 60. Now these units will have cubed because we've multiplied 3 lengths together. Okay, and it's as easy as that. Okay, this is a triangular prism, so as you see there is a triangle on the front here. It's a bit like a Toblerone, that's the best way to describe it. So when you do this, you do it very similar to the cuboid, so we'll multiply all the sides together, but the only thing is we'll half it, a bit like when you're finding the area of a triangle, you'd find the area as a rectangle and then half your answer. Just to be careful on these sorts of questions, when finding the area of the triangle, make sure you use the vertical height and the base. So sometimes they might give you this length here, so let's say that was 11 for example. Okay, and people then get confused of what length they actually need to use. Okay, so I'm going to add a right angle here just because I'm being picky. So I'm going to use the vertical height, which would be the 10, and the base of the triangle, which would be 8. Okay, you would only use that 11 if you were finding the surface area. Okay, so general formula. So again, I guess it might be easier if I use base actually. So base times height times depth. Height times base times depth divided by 2. So all of this section here is actually just the area of the triangle at the front, and then we've just times it by how far back it goes. So if we do that, so we've got a height of 10, a base of 8 and a depth of 12, and then we divide that by 2. Okay, I don't know whether these would be calculator, it would depend on the question, but for now I'm going to use a calculator just so that you know how to do it. So again, you can use a fraction button, which is really helpful and much speedier. Okay, so we get 480. Be careful of the units. Units are now meters. So 480 meters cubed. Okay. So the next one, I think the proper name is a trapeziumoid, but you don't need to know that anyway. So we've got a trapezium on the front. Okay. For the next part, you'll need to know that this is the cross section. Okay, and all that means is no matter where you would cut it, so let's say you were cutting down through the shape, you would always see that trapezium on the front. Okay, so what we need to do is we need to find the area of that trapezium first, and then we just times it by the depth. Okay, so the volume is the area of the trapezium, then we just times that by the depth. So the area of the trapezium, so this is where we add the parallel sides together, so 6 add 10, we divide that by 2, and then we times it by the vertical height, which is 4. Okay, so 6 add 10 is 16, half of 16 is 8, and then 8 times by 4 is 32 centimeters squared. Okay, so because that's area, that bit's squared, then we've got to multiply that by the depth. So 32 multiplied by 5, which is 160 centimetres cubed. So that's the volume. Okay. So the reason why I've called this a cross section is that you can use this formula for anything. So it's similar to this one. So volume. So you do the area of the cross section. Okay, it doesn't matter what shape it is. It could be a compound shape, because we've done compound shapes already. And then you just times that by the depth. Okay, so that's just how far back the 3D shape goes. Okay.